We've currently got pi comma negative 1, so we're going to have negative 1 comma pi. We've currently got 0 comma 1, so we're going to have 1 comma 0. We've currently got pi over 2 comma 0, so we're going to have 0 comma pi over 2. And this fellow here that I'm drawing now, that is called y equals arc. I can never remember how to spell this. Do I need 2 C's or 1? 2. That's called arc cos x. Okay, so it's the inverse relation, and obviously therefore a function of cos x. Why do I say obviously a function? Because we made it so. We busted our gut cutting out parts of the Loch Ness Monster so that it would be 1 to 1, and therefore the inverse would be 1 to 1. Okay. Now let's just check you're cool with how these work. So sine of pi over 2 is 1. So arc sine 1 will be pi over 2. That's the whole point. It's the back again. Okay. Now here's a little tricky one though. What about this? Sine arc sine, sine arc sine, sine arc sine. We've got the right number of brackets there. 1, 2, 3, 4, 5, 6 on the left. 1, 2, 3, 4, 5, 6 on the right. Okay, what will the answer to that be? I've just come up with a kooky little example where it goes back again, forwards, back again, forwards, back again, forwards. So what will it be? What works first? Sine of pi over 6 becomes half? Yeah? So what'll this do? Send it straight back to pi over 6, that's the point. What'll this do? Send it to half. What'll this do? Pi over 6. What'll this do? Half. What'll this do? Pi over 6. What'll this do? Half. So that's definitely half. That's the whole point. We cool with that? What about this guy? Sine, so arc sine sine What do you think of that? Remember, the whole point of these is that they just take stuff back again. What will the answer to that guy be? What do you think? We can just trace it through long and slow if you want. Should we trace it through long and slow? What's sine of pi? Yeah, pi is just 180. So start there, swing around, there's your fat dot. How high is that fat dot? 0, okay, so sine of pi is 0. What's arc sine of 0? Is it? Arc sine of 0, did you say? Okay. So how high is the graph there? 0, okay. This is where the fact that we restricted the domain means we really do have to think. Okay? Because arc sine does not work on any angles. Sorry, it does not work on any numbers that are not between negative pi over 2 and pi over 2. Sorry. Arc sine works on answers. It works on numbers negative 1 through 1. Yeah? And it spits out angles that are negative pi over 2 through pi over 2. It doesn't spit out pi. That's just not what it does. Okay, whoever invented this little ARC business got to make the decision, and he or she already decided that that's what it would do. Okay, so sine works on pi and gives 0. Arc sine then works on 0 and spits out 0. Sine then works on 0 and spits out 0. Arcsine works out on 0 and then spits out 0. Sine then works on 0 and spits out 0. Arcsine then works on 0 and spits out 0. So the answer to that is 0. Okay, so you must be very careful. Don't always just assume that if these are the back again functions of each other, that whatever is there will get spat out. Okay? If I'd done an extra one of those, what would the answer that be? That would now be pi over 6. So in this case, it did spit out exactly what went in. But in this case, it doesn't. Pi went in, but 0 came out. Okay? That's because of decisions that got made 100 years ago. Exactly what this arcsine business does. If you're inventing maths, you could make those decisions all over again. But they're gone. Those decisions are already done. You cool with that? Just the final one. Arc tan x. Okay, well, again, tan x is a super repeaty one. Just like this. That's many to one, right? Bit of practice what I preach here. Okay, so if we want that to be at least many to one when we take the back again, we'd better rub out all but one of these. And the one that we famously rub out, we rub out all the ones except the middle one. Okay, so the inverse of that is this. So that's pi over 2, that's negative pi over 2. And there we go. Okay, so it works on all possible numbers from negative infinity to infinity. Its domain is all real numbers.